Okay, I just stumbled on Alchemy, a TypeScript native ISC library where resources are memoized async functions that create, update, and delete automatically across runtimes.
Wait, seriously. That sounds like ISC, but you're saying it runs in any runtime, even the browser. That would blur the lines with client code.
Right, the core idea is you model resources as pure async functions, no separate DSL, just TS, so it composes like ordinary code with predictable lifecycle.
This makes me wonder about state persistence. If everything runs in the browser, where does the state live and how do you audit changes, rollbacks, and provenance?
Alchemy stores state locally in your project, not in a service. You inspect, modify, and commit state files, giving you repo-centric visibility across commits.
And the AI-first angle is wild. You can copy or fork resources using LLMs, so you can prototype without waiting for a provider feature.
Exactly, it lowers friction, but you must guard AI guidance to avoid drift or unsafe actions. It's a double-edged sword demanding better prompts and sane defaults.
Interesting. So it can run in a browser, but security becomes a concern if state and credentials live in the client, requiring careful isolation and auditing.
There are concrete examples. Cloudflare workers are two buckets, durable objects with an Alchemy, run TS orchestrating and wiring them together.
That sounds powerful, but how does it compare to Pulumi or Terraform? Is Alchemy replacing DSLs or augmenting them with lighter weight, TS native tooling?
It's Ease module native and browser friendly, no extra toolchains, making it embeddable anywhere. It's a different paradigm from Terraform that relies on providers and state backends.
But does no service mean you lose centralized governance, drift detection, and shared policies across teams? Or can you implement policy as code within resources?
Resources are just async functions, so you can compose, memoize, and reuse patterns. It's functionally friendly, but you still need architecture and naming conventions.
The AI first angle implies you can generate or copy resources on the fly. But how do you test or verify what the AI created, and who owns the final decisions?
There are examples and testing strategies in the repo, plus you can finalize app to delete orphan resources, which enforces cleanup and reduces drift over time.
If everything is in code and state is local, reproducibility should be good. Yet environment differences may creep in when runtimes swap between dev, staging, and prod.
Right, you can run to apply changes, and you can store state anywhere, so you might place it in a repo with CI checks, hooks, and diffs for visibility.
And the examples show AWS Lambda with DynamoDB, Cloudflare deployments, Nuxt, SvelteKit, wide coverage that demonstrates real workflows rather than toy cases.
The project emphasizes no strong opinions, so teams decide structure, storage, and conventions. You're not forced into a single mold, which is both liberating and risky.
That flexibility is great, but could lead to fragmentation if teams implement wildly different life cycles, versioning, and testing strategies without alignment.
The ES module native angle also points to bun-friendly runtimes, making the runtime choice part of the design and encouraging modern tooling.
One caveat: browser environments have limitations on persistence, service workers, and heavy infra logic, so some features may need server-side fallback.
Yes, but the key is state files stay in the project, so you audit diffs and review changes via PRs.
Secrets handling is curious. GitHub client ID and secret come from Alchemy, secret, process, env. That makes secrets explicit and traceable in code reviews.
Yes, secrets are retrieved via Alchemy Secret, which implies encryption concerns and versioning inside your repo and careful access control.
How about testing and staging? Are there end-to-end flows that simulate deployment, not just unit resource tests, so you trust behavior in production like reality?
There are end-to-end Cloudflare and Oz examples, including durable objects and pipelines, to validate behavior and catch integration surprises early.
Nice, but bundling and bundler compatibility could be tricky with all these runtimes, requiring careful bundling, code splitting, and module resolution.
Embedding allows local testing, but you still coordinate with the surrounding environment. The tool stays lean while you wire up infrastructure like you would in code.
AI first means potential non-determinism. How do you guard against surprises and ensure repeatable results, including audits and deterministic revisions?
Forking resources and tweaking them is encouraged, so you can tailor to your needs without waiting but maintain traceability of each fork.
But what about coverage gaps when providers aren't modeled yet? Can users patch their own resources quickly without breaking existing workflows?
The docs say no service and no strong opinions, so you can implement your own resources with a simple function and keep the shape familiar.
Yet syncing across runtimes could become tricky as you scale, needing tests for concurrency, idempotence, and conflicts across workers.
True, concurrency handling and deterministic execution remain challenges. The price of flexibility can be higher complexity and more debugging.
The really crazy part is you can use AI to generate or modify resources, then apply changes automatically, all within TS.
That fusion of AI with code-driven infra feels revolutionary and invites new patterns for how teams design behavior.
Wow, liberating but worrisome. Auto-modified infra could drift if not watched, and if prompts drift over time.
That's why governance, review, and rollback mechanisms matter. You can't just flip a switch and hope for the best, you need sane change control.
Adoption implications. Teams must balance speed with audit trails and peer review to stay responsible. Rollout plans, training, and clear ownership become part of the cost.
It blends code, data, and AI into infra. It isn't a silver bullet, but a new toolkit for brave teams to experiment with. If used wisely, it can reduce boilerplate while increasing rapid iteration and platform adaptability.
What about debugging and logs? Do we get traceability when resources are just functions that run and memoize? Perhaps you can attach metadata, step through calls, and review histories.
Yes, with local state and files, diffs and histories can be used. You can step through runs like normal code and reproduce results.
Can this scale to large teams and complex pipelines without becoming a brittle abstraction that breaks at scale? The answer likely depends on discipline and robust tooling around reviews.
Scale depends on discipline. TS native design helps, but governance and tooling matter to keep it sane. Introduce standards, linting, and CI checks for AI-driven changes.
Even so, the plug-and-play nature to hook Cloudflare, AWS, or custom resources is compelling and fast. Prototype end-to-end in days, then productionize.
It invites experimentation. The real test is building something meaningful and watching how AI aids or misleads you. The learning curve is real.
If I had to pick, I'd start with a tiny project and a clear guardrail for AI-generated changes.
Agreed, start small, define policies, and use PR reviews to catch odd AI suggestions before they become reality. Document decisions and iterate.
So what would you build first with Alchemy, if you had a weekend to experiment and learn the boundaries?
A tiny Cloudflare worker with a couple of resources and an AI-backed tweak loop would be perfect for learning the trade-offs and the workflow.
A weekend project could be a tiny Cloudflare worker with a couple of resources and an AI-backed tweak loop. It would teach trade-offs and invite the next experiment right.